Hi everyone! In this video, we will draw the engine pods of Skylon. And while I am drawing the engines, I will give you some background about what makes these engines so special. The way a rocket engine works is by mixing two chemicals, for example liquid oxygen and liquid hydrogen, and having them react to produce large amounts of gas. This gas is then ejected at very high speed at the rear of the rocket, and by doing this, you obtain a reaction force that propels the rocket forwards. But these chemicals have to come from somewhere. This is why rockets usually have large fuel tanks to feed the engines during the flight. Unfortunately, all this fuel is very heavy, and the further you want the rocket to go, the more fuel you need. But the more fuel you add to the rocket, the heavier it becomes. So you need even more fuel to push this extra mass of fuel that you just added. This is why most rockets are designed to drop stages during the flight to avoid spending fuel to push useless weight. Skylon has a very clever way to solve this problem. The engines are called SABRE. SABRE stands for Synergetic Air-Breathing Rocket Engine. And these engines are designed to have the best of both worlds: an air-breathing engine mode and rocket engine mode. At high altitude, the engines work like regular rocket engines, burning hydrogen and oxygen fed from internal tanks. However, at low altitude, the engines work like turbojets, which means that they take air from the atmosphere and use the oxygen from the air to chemically react with hydrogen. As a result, Skylon does not need to carry the oxygen used to feed the engines during the low altitude phase of the flight, because it can take it directly from the atmosphere. And this makes the spacecraft a lot lighter than a regular rocket, and this is what enables it to reach orbit without dropping any stage. Now, let's talk a little about the 3D printed model. The design of the rocket nozzles is similar to what we had on the BFR model, except that the shape of the nozzle is a bit different. As with the BFR, we will use 3 colors LEDs to light up the engines. What I really like with these LEDs is that you can daisy chain dozens of them, then you can tweak the software to change the color, brightness, and create very cool lighting sequences. And for those who wonder how the LEDs are connected to the control board located inside of the fuselage, well, you actually have wires running in a narrow channel inside the wings. But that's for another story. Each engine pod has 4 nozzles, but it is actually one single engine. In each engine pod, you have one combustion chamber, and then the exhaust gas are channeled to the 4 nozzles. Now, since the engines are designed for hypersonic flight, the front of the pod has an inlet cone, and this cone can be moved forward or backward to adjust the position of the air shockwave inside the engine. However, when the engine switches to rocket mode, the cone is moved all the way to the front, and this completely closes the air inlet. One of the effects is to reduce the air drag, and an additional purpose is to protect the engines during the atmospheric reentry by preventing hot air plasma to rush through the engine and damage the compressor. And since the moving inlet cones are one of the distinctive features of Skylon, we are going to put electric motors inside of the engine pods to have the inlet cone moves. So I hope you enjoyed this video. If you liked it, please don't forget to like, share, and subscribe.